Let's finish up the calculation that we had yesterday, where we were looking at a flux integral. We looked at how we were going to write the square, and drawing the square told us what the vector dA should look like. Remember, dA is going to have a magnitude equal to the area and a direction normal to the surface. So we decided that dA should be 0I plus dx dz times j. This is going to be a little piece of our surface. So if I look at the dot product of bxy dot dA, I'll find the dot product of our vector field, minus y over x squared plus y squared I, plus x over x squared plus y squared times j, dot 0I plus dx dz times j. So our dot product is going to be 0 from the I components plus x over x squared plus y squared times dx dz. Any questions? This is going to give us an integral, and we have to integrate over this surface. And the surface is writing the square this way, where x goes from 1 to 3 and z goes from 0 to 2, tells us how we're going to be integrating our flux integral. So our flux integral is going to be an integral. I could keep this order, dx dz, where x goes from 1 to 3. These are both constants, so I don't have to worry about. I can switch the order pretty easily. And then we're going to have x over x squared plus y squared dx dz. Now notice I left the y squared blank because going through this surface on this square, y is equal to 0. So I'm not worried about that. So really, we're just integrating from x from 1 to 3 and z from 0 to 2, the function 1 over x. I put my dx dz in the wrong order, didn't I? Writing a double integral, it's a rectangle. I had one job, put things in order. Fortunately, it's a nice rectangle, so I can just switch them without rewriting the endpoints. So we integrate the function dz, and then we'll integrate dx. And it's going to be just as easy because the function is just a 1 over x. So when we integrate dz, the integral of 1 over x with respect to z is just z over x, evaluated from 0 to 2. So we end up with 2 over x minus 0 over x. So we're just going to be integrating from 1 to 3, 2 over x to x. So it's going to be 2 natural logs of absolute x, which isn't going to matter in a minute, from 1 to 3. So 2 natural logs of 3 minus 2 natural logs of 1. Since we just did a problem where we talked about properties of logarithms, this is going to be natural log of 9. And these are all natural logs. So it's going to be natural log of 3 squared, which is 9, minus the natural log of 1 squared. So this will be the natural log of 3 squared divided by 1 squared. So this is going to be natural log of 9. So I wanted to finish up the calculation from yesterday. Any questions? Comments? Snide remarks? All right, let's stop the video here and talk about next steps.